Hey, ladies and gentlemen, we're going to continue with our discussion on intelligence and testing. We've talked today in class. We kind of ended here talking about some of the different percentages of those with mild mental disability, moderate mental disability, severe mental disability. These people may learn to talk and perform simple work tasks under close supervision, but are generally able to profit from vocational training. And then the lowest level is profound. Generally, their IQ scores are going to be below 20, and it's about 1 to 2% of the those who are disabled. And this fits fairly well with sort of the a bell curve on the percentages that are considered below normal. We'll get into that here in a minute. But all right, so how do we assess intelligence? There's Homer Simpson. One of the most widely used intelligence tests is the Wechsler Adult Intelligence Test, WAIS. It has a verbal and performance subtest. It is standardized. They define meaningful scores by comparison with performance of a pre-tested standardization group. So you have a group that is that's the standard, and then your score is compared to that group. And this generally hits the normal bell curve, the symmetrical, which we talked about in Unit 2. The symmetrical bell-shaped curve that describes the distribution of many physical and psychological attributes. Most scores fall near the average, and fewer and fewer scores lie near the extremes. All right, and here it is. We've talked some about this in Unit 2. I didn't get a whole lot into it because I knew we'd be tackling it here. But here's your typical bell curve, and it's called a bell curve because, this kind of looks like a bell, all right, with high in the middle and low. What this says is, and it's easy to use intelligence or IQ scores because this is what I was talking about earlier. Because the average is 100, and it just makes it easier to formulate the idea of what's going on. So if your average is 100, remember I said this, your standard deviation above and your standard deviation below is going to be, I think in this one it's 15. And 68% of your scores are going to fall within that 34% above or 34% below. So that's where your 68% of your scores are going to fall. So if you all, if the school took an IQ test, 68% of the people in the school would score between an 85, which is one standard deviation below, and a 115, which is one standard deviation above. All right, so that's where 68%. All right, the next group is 2 standard deviations above and 2 standard deviations below. This is where 96% of your scores are going to fall. So you've got your 34 in your first, let's say you're going above. You've got your 34% above the average, above the mean in your first standard deviation, and then 14% on top of that. All right, and then same thing going below the mean, 34% in first standard deviation, and an extra 14% in the second standard deviation, which is 130, 15 above and 15 below. In this one, 15 minus 85 is 70. 96% of the scores are going to be within that range. And then 3 standard deviations above, it's 2% is in that area. And then anything over 3 standard deviations is extremely small. You can kind of see that. So this is your standard bell curve. Again, the Wechsler Intelligence score is a good representative of that because everything is so it's sort of based around that 100. 100 is the mean, and then everything goes up and down from that. What they've found over the years is that average intelligence has gone up based on this Wechsler test. The average score, let's see, the overall score seems to be rising, as you can kind of see here. From 18 to 1996 standards, scores have gone up. So I'm not sure what that means, if people are getting smarter or if the test has changed. But it's just an interesting note. Can a test have high reliability but low validity? Absolutely. Your test can very reliably give you the same score over and over and over. The problem comes when that score is not actually measuring what you think it's measuring, as we talked about in the beginning of class. Can a test have low reliability but high predictive validity? No, it cannot. All right, if your test is not, if you're not going to get the same score multiple times over, if you don't have any reliability, then how can you say it's valid? You don't know if it's, that's the issue. You don't know if it's going to be valid or not. You don't know if it's measuring what you think it's going to measure. So you can have high reliability but low validity, but you cannot have low reliability and high predictive validity. It's just not going to happen. You could have a constant validity if it's measuring what it's supposed to measure. Here is an interesting graph. This looks at football linemen and their success. And this is using body weight as an example. All right, as the range of data under consideration narrows, its predictive power diminishes. Okay, so as you can see here, there is very, if success is from 0 to 10, all right, the higher the body weight, looks like the higher the success you're going to be. All right, but within this restricted range, this very small range from 280 to 300, if you just have that range, you don't see much correlation. All right, it's all kind of over the place. All right, but if you cover that up, or actually if you include the entirety, you can definitely see the trend is definitely upward. So that's another thing you got to be careful about, is how big is your range and what is it showing? If you've got a very small range, like what's within this shaded box, there's not much correlation here. All right, there's not within the change. But if you expand that out from 180 to 300, whoa, now you've got a large amount. You can definitely see the upward trend moving like this. With the higher the weight of the lineman, the more success he's going to have. All right, the dynamics of intelligence. We've talked a little bit about the stigma of the word retardation. We're not going to rehash that. I believe that is still the medical term. But I think the PC term we use in school is, I just lost it. Anyways, you know what I'm trying to say. It's Wednesday. Anyways, but it is a condition of limited mental ability indicated by an intelligence score below 70, I believe, on the Wechsler exam. So if we go back to the scores, all right, that is essentially 2 standard deviations and below the average, which is 100. Okay. Now, hopefully, you're starting to see how these all connect. But for somebody to consider to have a mental disability, if somebody is considered to have a mental disability, their intelligence score is going to be below 70. This produces difficulty in adapting to the demands of life, and can be very mild to very profound. There is a connection with Down syndrome, retardation, and associated physical disorders caused by an extra chromosome in one's genetic makeup. Again, that is not the PC term, but I believe that is still the medical term. Disability, I think, is the PC term. So, mental disability and associated physical disorders caused by extra chromosome in one's genetic makeup. Some other genetic influences is heritability, the proportion of a variation among individuals that we attribute to genes. The variability depends on a range of populations and environments studied. How much is our intelligence based on our parents' intelligence? What are the genetic influences? The most genetically similar people have the most similar scores. All right, and take a look at this graph. Kind of shows that a little bit. If I can get rid of this thing, identical twins have a high correlation. Remember, correlation is 1 and -1. 0 means no correlation. 1 is a positive correlation. -1 is negative correlation. Look at that Look how the graph is put together. Identical twins reared together have an extremely high correlation in their IQ scores. Identical twins that are reared apart are lower, as you can kind of see right here. Lower correlation than identical twins reared together shows some environmental effect. So again, remember, psychology is all about nature versus nurture. So the nature is the genes, the nurture is the environmental effect. So you can see there is an environmental effect. It may not be as high in this situation as the natural effect, but it's there. Fraternal twins reared together. These are the twins that do not look alike. They have a lower correlation than identical twins. And again, so this shows a genetic effect as well. Then you get to just siblings in general reared together. They're not twins. One's older than the other. And then unrelated individuals reared together. So these people are not people who aren't related at all, but are raised together. This could be a mixed family with a group of siblings from the father and a group of siblings from the mother, and now they're maybe reared together that are young. There is a slight correlation there, but it's not as much as identical twins. So the point of this is, again, to show that there is genetic influences between, but there are also some environmental influences that influence IQ. Some other influences is the child-parent correlation in verbal ability scores, children and their birth parents, adopted children and their birth parents, adopted children and their adoptive parents. All right. Look at that huge jump when they reach 16 years. All right. But what's interesting is there's not near the separation between children and their birth parents and adopted children and their birth parents until you get to 16. So, and there's even less correlation with adoptive children and adoptive parents. So just looking at some of that genetic influences. But they're not the only ones. Again, there are environmental influences, intelligence test score gains relative to a grade 4 baseline. So remember, these are ages in months down here. So there is an increase in intelligence as students go through school. Of course, there are group differences as well. Group differences, environmental impacts. If you've got some seeds, you put half of them in poor soil, half of them in fertile soil. Obviously, the fertile soil ones are going to do a whole lot better than the poor soil ones, even though they're from the same packet of seeds. So there are changes within certain groups. There are also differences in genders. Males, females as a group on score. Males are equal to females as groups on math test mean scores. Females are higher in computation, but males are higher in problem solving. Again, these are general. An interesting fact is that males have a greater differentiation within the group. Differences can be explained in socialization differences. Black and white males and females. Males are better on spatial tasks and probably evolved from having to hunt in 3D space. And then a biological perspective, prenatal male sex hormones may have something to do with that as well. Females are better on emotion detecting. From the evolutionary perspective, women's ability to detect emotions help them to read emotions in infants and or potential mates. Assessing intelligence, sample items from, so y'all were asking about if we're going to take some. So here's some sample items from the test. At least here's what they look at. On the verbal side, they look at general information, just what do you know, your ability to detect similarities, your ability for math reasoning, your vocabulary, your ability to comprehend, and digit span. I'm not sure what that is. And then on the performance side of it, you have a picture completion. So you'll have half of a picture, and you're going to have to decide which selection finishes the picture. Same thing with a picture arrangement. You're going to have some blocks you're going to have to deal with, object assembly, and then digit symbol substitution. Again, here's sort of that same things that you're going to be looking at: abilities, visual spatial abilities, perceptual speed, all these things. You can pause this if you want to take a look at those if you're so inclined. I'm not going to read each one. So here's where you ought to be able to do at certain ages. All right, at age 2, you should be able to place geometric shapes and corresponding openings. You should be able to identify body parts, head and shoulders, knees and toes, knees, toes. All right. Should be able to stack blocks and identify common objects. Cup, lamp, chair, table. At 4 years old, you ought to be able to name objects from memory, complete analogies. Fire is hot, ice is cold. Identify objects of similar shape, answer simple questions, things like that. At 6, define simple words and explain the difference between things like a horse and a fish. Identify missing parts, things like that. And then at age 8, answer questions about a simple story. Identify absurdities. John had to walk on crutches because he hurt his arm. Things like that. I'll let you all pause this to kind of see what you ought to be able. So as adults, at some point, you should be able to supply several missing words for incomplete sentences. Repeat 6-digit numbers in reverse order. Create a sentence using several unrelated words. Describe similarities between concepts, teaching and business, etc. So some questions that might be on the intelligence part. What day of the year is Independence Day? July 4th. In what ways are wool and cotton alike? They can both be spun into cloth and clothing. If eggs cost 60 cents a dozen, what does one egg cost? 60 divided by 12. It's 5 cents, I believe. Tell me the meaning of corrupt. What does it mean to be corrupt? Why do people buy fire insurance? Listen carefully, and when I am through, say the numbers right after me. 867-5309. Now I'm going to say some more numbers, but I want you to repeat them backwards. 867-5309. And then you just have to say it backwards, which I'm not going to do right now. And then for a performance, picture completion, what's missing? What's missing? What's missing? Performance, picture arrangements. Put these in order of what it might happen. So which one's first, which one's second, which one's third, which one's fourth. So he's going to run outside first. He's going to make part of the snowman second. He's going to finish snowman third. He's going to call his friends to look at it fourth. Same thing here. There's a couple different ways you can. But he's in bed. I guess we can it can be either the beginning or the end. I'm going to just say this is the beginning. Goes to work or school, sits in school, comes home. And then examples of block design. You have these, and you need to put the blocks together to make this. All right? Kind of see how that works. So you're given the blocks with these on it, and then you've got to make that. Object assembly. Here's what you need. Here's what you got. You need to put it together like this. Here's another example of that. That's pictures of dog. Give sequence of letters and numbers, and the subject reorders them. Numbers first, letters second, range numerically and alphabetically. So if you got 8GD61S2, it becomes 1268DGS. Digit symbol substitution. So essentially this is just code. So triangle is 1, circle is 2, 3, 4, 5. So you basically this would be 1, 5, 4, 2, 1, 3, 5, 4, 1, 5. Yep. Same thing here. Matrix reasoning. If that equals that, then that equals which one? It'll be that one, right? Same thing here. Which one of these fits there? Here's another example. So that was Wechsler's. Now, a guy named Thurston come up with a different thing. I want to see how long we've been going. Actually, I don't know. Can't tell. I'm going to pause it. Actually, we've been going for a while. Let's go ahead and stop now. We'll continue with this tomorrow. Thurston. So, hope you have a good evening. Stay warm. Peace out.